Good morning, everybody. We are team number 1, which I compose of Jenny, Sarah, Renata, and me. We will start with our ancient topic, which was how to obtain a textile for a shoe or tennis shoe fabric. The relevance of obtaining a textile material that satisfies certain purposes, such as footwear and chemical finishing, helps recognize and reinterpret the components of the textile product. Specifically, on our case, we are going to talk about how a tennis fabric is made and the reasoning behind our decisions after reaching the consumer.
Our project will be about to prove our understanding of textile fibers and their properties, fabric construction, and finishing processes. To back up our decision-making process, we must be doing our research, solving problems, and discussing the options. It's fundamental to make use of everything that we have learned, and that's why when we are finished with the project, we will have integrated the knowledge acquired in transcendental subjects of textile engineering, such as fibrology, spinning, weaving, and finishing. These subjects will help us analyze the final uses and properties that the product requires.
And here we have the reasons that explain the justification of our project, which we will further talk about throughout the slides. First, we have protected our feet since we started to walk. Thus, the material selection has to have a purpose, and we also have to know the flow of the process.
And shoe or tennis shoe. We choose a tennis shoe instead of a user shoe, as it seemed a much more interesting option. And as a team, we had several ideas of what we want to do with this choice.
What properties will we focus on? The first one will be the design and the quality of our final product. We consider this is a very crucial aspect to consider in the development of our tennis fabric, because sometimes we don't understand the importance of looking at the quality of the footwear we use every day. It is overlooked and it has serious consequences in the well-being of our feet and therefore our overall health. The other one will be the durability. Being long-lasting helps the environment, since we will not be getting rid of it too soon and we will avoid causing more garbage. The last one would be the any other. Being a product that we use for a long time, it is convenient that it has this feature to eliminate bad odors caused by sweat.
Tools. The chosen material for the tools is synthetic rubber. We must remember that we obtain the synthetic rubber we will by vulcanizing natural rubber by adding sulfur to the molecule, making it more resistant and stable.
The reasons why we chose the synthetic rubber for the soles are its durability and lifespan is much better than foams or polyester. The resistance it has against different types of soil or thrown objects such as glass or balls. And black soles appear to be less dirty than white soles. Also, the union of the sole with the fabric is by using heat, and adhesives may cause allergies or negative skin reactions.
And what type of fiber we choose? The chosen fiber is cotton, which is a natural fiber that is also known as gossypium plant. Its polymer is cellulose and its monomer is glucose.
Because it's absorbent, allowing the skin to perspire. It's not thermosetting, not thermoplastic fiber, which means it will not melt or soften when subject to high temperatures. The density of the 1.52 gram per cc we perceive is a high covering power.
The yarn will be a ring yarn made of carded cotton.
And it is a 30 English number, so why must it be coarse? Because we need a yarn with strength and a regular surface. We want the fibers to stay together for a long time, and if we were to use open-end yarn, that has false twisting, we may run the risk of the yarns breaking and ending up with holes in the fabric. The yarn shouldn't be combed nor semi-combed because we do not need fine calibers. The processing steps to make the yarn will be opening, carding, first stage drawing and second stage drawing, roving, clearing, splicing and winding, spinning, and assembly winding.
For the structure of the fabric, we need it to be resistant to maintain the position of the yarns all the time, so we choose plain weaving, since it does not deform as easily as knitted fabrics. The ligament we chose is taffeta, because it's the simplest ligament and the appeal of this tennis comes from the printed design on the top of it. It also provides great coverage, which is necessary to protect the skin.
And the processing steps are warping, sizing, nosing, and waving.
And now we move on the wet and finishing processes.
The pre-treatment processes for the entire taffeta production are: number 1, we need singeing, but why? It is required to remove the linters from the surface of the fabric and improve its appearance. It's given in the singeing machine and the fabric is exposed to flames of about 1100 degrees Celsius at 80 meters per minute. The following step is number 2, is to give de-icing, scoring, and bleaching at the same time, because the chemicals are applied in a cold bath and the plastic-coated fabric rolls are left to rest for 8 hours. The pad batch was chosen because it allows us to split production, and the formulation of the DSB bath is 10 grams per liter of moistening agent, which helps the fiber to absorb liquids quickly, 20 grams per liter of sodium silicate for bleaching, 15 grams per liter of sodium hydroxide at 36 Baume degrees, which provides the alkaline pH of the bath, 25 grams per liter of perammonium sulfate for starch de-icing, and 50 grams per liter of hydrogen peroxide for scoring. And number 3 is once the time of contact with the chemical of the fabric is over, the next steps are the washes in an open width washing machine. The first wash is a neutralizer one with acetic acid at 60 degrees Celsius, and 3 rinses are given at 80, 60, and 40 degrees Celsius.
The next step is the number 4, and it's to give dimensional stability to the pre-shrink the fabric, and half of the production will be optical brightened. So before entering the standard machine, these chemicals are applied. 5 grams per liter of moistening agent and 1.5 grams per liter of optical brightener, responsible for optical brightening. The other half of the production is only giving the required dimensional stability without applying any chemicals before entering the standard machine. The next step, the number 5, the half that was given the optical brightener is left to cool, and the other half that was only given dimensional stability is prepared for printing. The application of chemicals is done in the pad batch, and for each kilo of fabric, they are added 400 grams of alginate as thickener, 20 grams of sodium bicarbonate as fixing auxiliary, 10 grams of quick oxidant to avoid dye reduction by the alkali, and water. Afterwards, it will be dried in a steam-operated hot air box. So far, the pre-treatment processes are done, and we continue with the printing process.
The printing pattern. The printing pattern is given to add a colorful designs to the textile, and it is done in a digital printer with reactive dyes passed ink. The temperature of the room which has the digital printer is 15 degrees Celsius to avoid the clogging of the printer head. The range of the printing pattern is given to 80 degrees Celsius in the hot air box. and the fixation is done at 120 degrees Celsius. The rings are given to remove the product that were not fixated in the textile surface, and it is done in the open weight washing machine, stirring with the neutralizing bed with acetic acid at 60 degrees Celsius, and the next rinse are given at 80, 60, and 40 degrees Celsius. Once the fabric is washed, it is dried in the hot air box at 80 degrees Celsius. And now we see some example of the printing designs.
Finishes processes. The chemical furnaces applied to the entire production are hand building finish, a flexible rigidity and anti-odor, because the hand building allows the fabric to maintain its shape without discomforting the user, and the anti-odor finish will help avoid bad odors that are produced by prolonged use of these tennis shoes. The chemicals are applied on the pad batch, and modified polyurethane and cyclodextrins with zeolites are added. The modified polyurethane gives the hand building finish and is also used as a binder for the zeolite with cyclodextrins, which trap and destroy various odors. To polymerize the modified polyurethane, the fabric is taken to the hot air box, where it's subject to temperatures between 140 to 160 degrees Celsius. And then the last processing steps to finish the tennis shoes are: number 1, cut and confection. Then assembly of soles and fabric. Taking, baking, and distribution.
And to summarize our experience with this project, it is very important to consider all the components and its functionality in the final garment. We must understand the purpose and flow of the production process. And we want to mention that it was a challenge for us to try and remember all our acquired knowledge throughout our classes. And now we realize we can point out the general processes in the fabric making industry, and we cannot wait to see all of it in real life. As always, we consider the teamwork was very effective for all the members of the team, and we managed to reinforce our knowledge, study, and learn from each other. The last slide was our references, and we are ready for your questions. We are here for it. Thank you for your attention.